Okay, here's our gas law problem. A 22-foot cubed cylinder of oxygen is at 73 degrees Fahrenheit and a pressure of 650 psi G or psi gauge. The cylinder is put in the sun and the temperature increases to 120 degrees Fahrenheit. What will be the new pressure in psi G? Round your final answer to the nearest hundredth. Hint, standard atmospheric pressure is 14.7 psi. Make sure you convert pressure to psi-A and convert temperature to Rankine. Okay, so with these gas law problems, basically what you're doing is you're defining state 1, which is given, and then some change is happening, and then you're going to state 2. In this case, the temperature increased. So that's going to have an effect on the pressure. So the 22-foot cube cylinder, what we have here is a cylinder. So a cylinder is always going to have constant volume because just like you see like a welding cylinder or whatever type of cylinder it is, this is a metal cylinder and the volume of this is fixed. So the volume won't change. That's why we're not worrying about the volume in this issue, in this problem. All right, so, okay, great. So let's go ahead and look at what we have. We have, first is given is our temperature is 73 degrees Fahrenheit. And also our pressure at state 1 is 650 psi. Then it's put into the sun and the temperature increases. We can probably assume that with the temperature increase with a fixed volume, we're going to have a pressure increase, right? But we need to make sure that everything's absolute value. So we have our pressure needs to be an absolute value and our temperature needs to be an absolute value. Remember that your temperature, the absolute scale, is based from absolute zero. What's absolute zero? That's when the temperature is at zero, there's no molecular movement, right? So Fahrenheit is not an absolute scale, so we have to convert it to an absolute scale. And then with our pressure, gauge pressure, that's normally what you're going to be dealing with 99% of the time is gauge. That's like you go out and you put a gauge on your tire and it's going to read a pressure. What that pressure is actually reading is the difference between atmospheric pressure, which is 14.7 psi, which is out here around the tire, and what's in the tire. So it's a difference between these two. So actually what's in the tire is going to be this 30 psi G, or this 30 psi, plus it does have atmospheric pressure in there, plus 14. So this is going to be in that tire, the absolute pressure in that tire is actually going to be 44.7 psi. But a gauge, again, reads the difference between these two pressures, right? If I flatten this tire, I put a nail in this tire, and all the air left, there would be 14.7 psi inside this tire, 14.7 psi outside the tire, and this gauge would read 0 psi because there's no difference between these two. All right, perfect. So we just have to remember, deal with absolutes when we're doing these gas laws. That's where you're going to make a mistake. All right, so here we go. We have our temperature 1 is 73 degrees. So let's go and convert that to Rankine. So with Fahrenheit, we just need to add 460 to this plus 460. And that's going to come out to be 650. Sorry, not 650. 533 degrees Rankine. That's T1. And pressure that's engaged, so we need to convert it to absolute. So what we need to do is add 14.7 psi to it, so 664.7, and now we're in psi absolute value. Okay, good. So we have these two values. This is the one I'm going to use in the formula, and this is the one I'm going to use in the formula. So the last thing that's given, this is all state 1, and then at state 2, something happened, right? The temperature increased. So we have temperature 2, it went to 120 degrees Fahrenheit. But we can't use Fahrenheit, we need to use absolute scale, so we need to add 460 to this. So that's going to come out to 580 degrees Rankine. Okay, perfect. So we have our three values that we need, and we're going to end up solving for pressure 2. That's the only thing that's missing, right? So we just need to make sure that we plug it into the right spots. So this is pressure 1, This is pressure 1. So we're going to put that over here with P1, 664.7. Then we have T2, so we're going to plug it in, 580 degrees Rankine. Then we have T2, then we have P2. That's what we want to solve for. And finally, we have T1, which is 533. Okay, so great. Now we're just going to solve this with algebra. We just need to get P2 by itself. So we're going to divide this side by 533 and do the same thing on this side. 533. 533 divided by 533 is just 1. We're left with just P2 on that side. And if I plug all this into my calculator, what's going to pop out is 723.3133208. And this is in PSI A. But it doesn't want absolute pressure. It's asking you for what the gauge is going to read. So we should understand that what we need to do to this is just subtract 14.7 from this value. The other thing to do with these problems is don't round until the very end of the problem. If you round before any of this, before the end of the problem, you're not going to get it correct. So just try to keep all the digits in your calculator. Okay, so this is going to be PSI2 is going to be 708.61, and now we've converted back to PSIG, and that's our correct answer.